Hey guys, today we start 9.1 bivariate data. We're going to start off with a basic lesson about just making a scatter plot, being able to determine what goes on your x-axis and your y-axis, as well as being able to make scatter plots so that their increments are equal, and you can really see that relationship between the scatter plots. So bivariate data it's used to explore the relationship between two variables. Okay, so this time, instead of giving you one list of numbers, you're going to get two lists of numbers and talk about the relationship between those two lists of numbers. It's a good display for two variables. So your explanatory variable goes on your x-axis and your response variable goes on your y-axis. And usually what I say is the explanatory variable changes, and what is the response of that explanatory variable. So here, when I'm describing the relationship, the way that you want to describe it is you talk about how x is changing and what y is doing it because of that change. So explaining what changes and what the response is to that change. So in this case, height is going to be my explanatory variable, which means that weight is my response variable. So as x, and I'm going to say as the height increases, and we always talk about your x variable increasing because typically for these the context doesn't really make sense for height to be negative. And what's happening to the y's? So the y's are getting bigger, so the y variable is increasing. So as height is increasing, weight is increasing. And that's really how you're going to describe the relationship between your two variables. As the x changes, how does the y change? Here we have an example where it asks if this is bivariate data. And the way that we know that it's bivariate data is because we have two different variables that we're comparing. So yes, because we have two variables that we're comparing. Our two variables that we're comparing are the number of weeks in the top 40 and it's going to be the number of singles sold. Okay, so in this case, as the number of weeks in the top 40 increases, what do you notice is happening to the y value as it's moving to the right? So top 40 increases, the number of singles sold decreases, so this time it's going down. So pretty basic, just to start us off. Now we're going to talk about how to make a scatter plot. So the first step to analyzing your data is making a graph so that we can look at the relationship between those two variables. So this is an example where we're looking at golf, and we're looking at different golfers, and we're comparing their driving distance to their driving accuracy. And we want to ask ourselves, which one is our explanatory variable? Does driving distance affect accuracy, or would accuracy affect driving distance? And it's more likely that driving distance would affect accuracy, which means that the average driving distance would become your explanatory variable, which would go on your x-axis, and driving accuracy would go on your y-axis. So one easy way to lose points is to not label. Make sure that you always label your graphs. This will help the reader know what the actual graph is talking about. And you really want to utilize all of the space that's given to you for the scatter plot. So what I mean by that is we don't want to have like a little scatter plot that's just right here. And similarly, I don't want to be all over the place. I don't want to see it. I want to make sure that I can kind of see the relationship in a clear way. I want to see that relationship and what it's actually doing. Because when they're clustered together, it's really hard to see what's actually happening for the graph. So the hardest part about this is just making your axes correct. So the way that I think about it is I say, what is the smallest value that I see on this graph? And just looking at this quickly, I see 245. And then I ask myself, what's the biggest number that I see on here? And I see 269.2. So I've got to go from 245 to 269.2. So maybe what I'll go by is 3s. So starting at, if I don't want to start at 0, I do this little squiggly thing that says some time has passed. And usually that helps me zoom in on what my graph is actually looking like. So I'm going to start at 245, and I'm going to go by threes. So 248, 251, 254, 257, 260, 263, 266, 269. Okay? And then I'm going to look at my y-axis. So my smallest value on my y-axis, it appears as the 0.654. And my biggest point that I see is the 0.824. So I've got to go from 0.65 to 0.824. So a little bit of time has passed. And then we're going to start maybe just at 0.65. And maybe I go by fives here. So 0.70, 0.75, 0.80, 0.85. Now that's not me really utilizing the entire graph. So something better would be to go by twos, to go by threes, just to make your data more accurate. And then you're plotting just as you would plot like coordinates on a coordinate grid. So 246.824, 265, okay, and sometimes I'm going to pass a little bit. I'm going to just try to plot all these rather quickly so that you're not waiting too long for me to keep talking. So all I'm doing is just going through my list and I'm plotting the various points as best as I can. We're making a scatter plot by hand, so it's not going to be perfectly accurate, but it will help me see the relationship between my data. All right, so there I've got my relationship and I can ultimately see what's going on. So as driving distance is increasing, notice that my Y's are going down, so accuracy is decreasing. Okay, I'm gonna let you guys try the next one on your own about making ice cream sales versus temperature. I bet you can already think about as temperature goes up, obviously what's going to happen to ice cream sales. And then I want to go into making scatter plots on the TI-84. So on your teacher's page, if this is the posted PowerPoint, you can click this link. And from the link, it's going to take you to step by step for how to use the TI-84. Not necessarily, don't have to necessarily be able to do it in this class, but it's going to be really useful for comparing and making linear regression. So starting that linear regression steps that we're going to go into in the next couple of lessons. Okay, make sure that you ask your teacher any questions if you need help.